Hello, and what we're going to be doing here in this video is talking about the discriminant. And the discriminant is simply a part of, technically it's just a part of the quadratic formula. You can see here I have the quadratic formula written out, and the discriminant refers to this part, okay, right here. What's right underneath this radical, that is the discriminant. Now, why is it useful to us? It's actually very useful, and you can see here I have a nice little quadratic equation for us. And just kind of give you the broader perspective here. Remember, if I have a quadratic equation, I can try to solve this by using factoring or other methods, but you can always solve a quadratic equation by using the quadratic formula. That's what makes the quadratic formula so useful. But the one thing about quadratic equations, okay, and let's just make sure you understand, quadratic equation is a polynomial to its highest degree, or its degree is to 2. Okay, it's a second degree polynomial. That means there's always two solutions. Okay, there's always two roots. Okay, now what type of solutions, nobody really knows until you actually start looking for them. And they could be real numbers or complex numbers or some sort of combination in between. Okay, in other words, you could have imaginary numbers or just basic real numbers as roots. And the discriminant basically helps us determine the type of roots a quadratic equation will have. All right, so how does it work? Well, let's go ahead and actually find the discriminant of this particular quadratic equation, and I'll start explaining some ways to interpret the discriminant. We're interested in simply the sign of b squared minus 4ac, but let's go ahead and calculate it for this one here. So recall that a, if you were going to plug all these values into your quadratic equation, a would be, or quadratic formula, excuse me, a would be equal to 4, b is negative 2, and c is 5. So b squared minus 4ac would be equal to negative 2 squared minus 4 times a, which is 4, times c, which is 5. Okay, so we can go through, do the math. Negative 2 squared, positive 4, minus 4 times 5 is 20. 20 times 4 is 80. So when I do this, I'm going to get a negative 76. All right, so b squared minus 4ac in this case was equal to negative 76. Now think about that. If we were plowing through, working on our quadratic formula here, we would have we'd have to take the square root of negative 76, because all of this right here, okay, this b squared minus 4ac was equal to negative 76. So I'm not concerned about the 76 part here. It's not what we're really going to focus in on with when we're talking about the discriminant. I'm just concerned that it's a negative number. All right. Now, if you went into your calculator and try to find the square root of negative 76, your calculator is going to come back as it's going to give you some sort of error message. That's because your calculator works in real numbers. Okay. The square root of negative 76 is in fact a imaginary number. Okay. So you would really have to mathematically pull that negative out and write it as a square root of 76i. So what does that tell you? It tells you that this particular quadratic equation right here, because its discriminant was negative, all right, because we ended up having to take the square root of a negative number, that we're going to have two imaginary roots, okay? Two imaginary roots. Now, let me go ahead and just break this down for you. So b squared minus 4ac, that's the discriminant, okay? So when the sign is negative, like in this case, for example, we had the square root of negative 76. When you have a negative discriminant, that means you're going to have two complex, or you're going to end up with an imaginary number in that radical. So it means that you're going to have two complex roots. All right. Now, if you have a positive number as your discriminant, so let's say the square root of a positive 76, that means that when you finish doing your quadratic formula, you'll simply have two real number roots. Okay. And one neat thing is if you have the discriminant equal to 0, all right, you're going to have what they call one double root. One double root. All right. So that's it. Okay. B squared minus 4ac, whatever not the value, it's the sign. Okay. So if it's b squared minus 4ac turns out to be negative, you have two complex roots for your quadratic equation. If it's positive, you have two real roots. If it's zero, you have one double root. Now, I want to show you here what this means graphically. I'm going to erase this. And graphically, remember that a quadratic equation, all quadratic equations when they're graphed, they all graph in the form of a parabola. Okay, so a parabola that crosses through the x-axis right here. Okay, these two locations, the x-intercepts, represents the real roots. So here, clearly, I have a parabola, quadratic equation that has two real roots. So guess what? It's discriminant. All right. Oops. B squared minus 4ac. Its discriminant must have been what? Well, it must have been positive. So I can write this using inequalities. In other words, it must have been greater than 0. It was positive. Now, I can also have a situation where if the graph of my quadratic equation, okay, another parabola, but it doesn't cross through the x-axis, well, if it doesn't cross through the x-axis, this is a situation where you have imaginary or complex roots. So that's when you have your discriminant as a negative number or it's less than 0. All right, that just means that it's a negative number. And then you have the situation where your discriminant is equal to 0. Okay, and that's when you have double roots. So here's another parabola, and where a parabola bounces off the x-axis, okay, let's say suppose this was negative 10 right here, that point is a double root. Okay, so where anytime you see, like I said, a parabola bouncing off the x-axis, that's a location of a double root. Means that both roots, okay, your both solutions are the same number. Okay, one, for example here, one of the solutions would be negative 10 and the second one would also be negative 10. That's when you have the discriminant equal to 0. All right. Okay, so basically, once again, a discriminant simply just tells you the type of roots for a quadratic equation. And, you know, it is a very useful thing. Most of you aren't going to be calculating the discriminant, you know, if you're looking for the solution to a quadratic equation. You'll just kind of notice that as you're doing your work using the quadratic formula. All right, hope this video helped you out. Good luck.